Hello everyone, welcome to 3IAM's Data Engineering Volume 2 course. And this volume will delve into the data processing, wherein I'll talk about both batch and stream processing. And the technologies would not be that high. I'll be using only a few technologies, but the span of the course would be pretty big because the technologies that I'll be talking about here would be the ones that most of the data engineers work on. For example, Spark. Spark is something that you have to know as a data engineer. If you consider yourself as a data engineer and if you do not have Spark knowledge, then it would not be considered by the recruiters or any organizations that you are a data engineer. Spark is essential for any data engineer for that matter. Now, Spark can provide both batch and stream processing. In batch processing, Spark can use data sources like file formats, Parquet, Avro, ORC, JSON, etc. It can also use databases or OLTP databases, relational and non-relational, and it can also use data warehousing system. Spark also supports stream processing, wherein it gets data from a real-time streaming ingestion platform like Kafka and then does the processing, and after that it stores the data into various different data stores. So I'll be focusing on Spark and Kafka in this particular course and the data platforms that are used to host these type of technologies. Spark is an open source data processing framework, so is Kafka, but there are various data hosting platforms or data platforms that provide managed services on Spark and Kafka. I'll be using AWS services like EMR or Elastic MapReduce and MSK, which is managed streaming for Kafka on AWS. And then I'll talk about Databricks, which is another data platform, and it provides a plethora of integration with various other technologies also. So this is what I'm going to focus on in this particular volume. Also, I'll be talking about data orchestration pipeline using Apache Airflow, and AWS provides MWAA, which is managed workflow using Apache Airflow. So I'll be talking about Apache Airflow also. As of the time of this recording, I have not put in the Databricks course yet, but I will put the Databricks course pretty soon. Now, first of all, thank you very much for your support and thank you very much for buying the course. And I really appreciate. I'll try my best to help you learn whatever technologies I discuss in these volumes or in these courses. Please feel free to drop questions in the comments or feel free to ask questions, or you can discuss it in the live chat also. But if you are asking questions in the comments or Q&A section, then it might take 1 week for me to respond because typically I look at the questions once a week. Now, as it is a data engineering course, obviously it is imperative that I start with the definition of data. What data is? The technologies that are associated with data are in high demand. So what exactly data is? And this is the simplest definition that I could give you. Data is essentially information, which is collection of facts. Now, when I say facts, facts are nothing but the things that are happening around you, which are tangible and quantitative, meaning that they are actually happening. Those things are happening physically. You can see that, you can feel that and touch that. And data is about the information of those facts that are happening around us. And the things that happened around us, or the facts that I'm talking about, those are quantifiable. So as those are quantifiable, those should be measurable as well. So data is essentially the measurements of those quantifiable facts that are happening around us. So that's what data is. And the next question might be which domains data is used for. Of course, this particular slide or any PPT for that matter is not enough to talk about the domains and the business organizations which are using data, but just a fraction of it that I'm going to discuss here. These are the business domains where data is getting used day in and day out. Finance and insurance, like banking systems, insurance systems, it can be health insurance, car insurance, home insurance, etc. In energy sectors also, data is getting used because you see movement towards a sustainable future. So that's where windmills, solar panels, etc. are getting used. And what happens is that data from those devices are captured and analyzed for further optimization. Same is the case with manufacturing. And manufacturing means it can be any manufacturing. It can be as small as a spoon that you use in your kitchen, or it can be as big as creating heavy machineries. It can be cars, etc. And everywhere data is used. A car manufacturing process, at every assembly line, a lot of data are generated, and those data are analyzed to streamline the assembly process and streamline the car manufacturing process. In healthcare domains, so patient records, testing results, testing reports, etc., everything are captured as data because those are quantifiable, and those are used by the doctors and the healthcare providers to make our life better. Same is the case with education. Of course, this is also an educational video. We also use a lot of data in education systems, and there are approximately 500,000 universities around the world, and at any point in time, as per the records, we see that there are approximately 250 million students learning around the globe. So you can imagine how much of data are getting generated and how much of data are getting stored for all those. The university information, the information about the students, information about the courses, etc. are stored as quantifiable points, or those quantifiable points are stored as data. Government sector use a lot of data. It can be any public sector organization that falls in the category that I have already mentioned. It can be military, it can be space research, it can be anything. And of course, marketing is one of the places that data is used a lot. And you can see that in your day-to-day life also. The other things might be obscure from you, but marketing is something that you'll see in a daily basis. If you do online shopping, if you go to amazon.com, or if you go to any other e-commerce places, websites rather, you'd see that they give you recommendations that these are the things that you should buy, and those recommendations are generated based on your buying history. So which means that the buying history is also stored somewhere, and those are stored as quantifiable and tangible points, which are nothing but measurements. So using those measurements, all these retail organizations send us targeted marketing content. Same is the case with offline retail and e-commerce also. Transport and logistics use a lot of data. Let's say there's a truck which is carrying fuel for cars or airplanes or etc. And what happens is that there are devices fit inside of the truck which keeps on sending data maybe every 5 seconds or 10 seconds or 15 seconds, just to see that the driver is following the proper route or not. If the driver is not following a proper route, then certain action can be taken. The driver might be requested to follow a particular route. Same is the case with train journey, buses, same is the case with flights, etc. And of course, it goes without saying that social media use a lot of data like Twitter, Facebook, etc. A lot of data are generated there, and those are used also for marketing, advertisements, etc. These are just some of them. There are other usages also. So whatever data are generated, those data are used in these type of applications or these type of use cases. For example, predictive analytics, which is nothing but marketing or the targeted marketing that I was talking about. Fraud detection is one of the very important use cases wherein data is used. So let's say you have made some credit card payment of maybe $100,000. Typically what happens is that you do not do such high value shopping. So it might be a fraud who is trying to impersonate you and trying to steal money from your credit card or trying to use your credit card. So what happens is that to avoid these things, all the finance organizations implement something called fraud detection, and the fraud detection algorithm uses the historical data that you have. Research and analysis use a lot of data. Monitoring like server monitoring, ship monitoring, flight monitoring, etc. use data also. That's why data is also used. Risk management is another place where data is used. Again, the data for risk management is generated from finance, insurance, healthcare, and other domains. I have highlighted AI and ML, which is artificial intelligence and machine learning. And Gen AI or generative AI fall in the category of AI and ML. So the reason I have highlighted this, because you have to understand that whether you use ChatGPT or Gemini or Nova, whatever it is, they use a lot of data to train their machine learning models. Now, to train their models, they need fair amount of data, and all those data are generated by various applications, and then those are fed to the machine learning models, and that's how the Gen AI models are generated and then used. For example, the foundation models or the large language models that you see today. Operational analytics, decision support system or DSS, customer experience, all these also use data from the applications that generate them. So left hand side are the applications which generate data, and the right hand side are the use cases where data is used. Last but not the least, autonomous driving. As you already know that autonomous driving is gaining momentum nowadays, and what happens is that there are multiple sensors, there are multiple video sensors, audio sensors, and a lot of other devices which are there in the car, and all of them generate data of the surrounding of the car, and then a machine learning model or analytics happens on those data so that the car can drive itself. So autonomous driving also is a place where data is used a lot. As I said, the left hand side are the domains where data gets generated and also used, and the right hand side are the use cases. Of course, you can imagine that there's a journey that happens from the generation of data and then the use of that particular data. And that's what data lifecycle is, or data pipeline is. You can call it either data lifecycle or data pipeline. Anything is fine. And in this particular slide, I'm going to talk about the process of the data lifecycle at a very, very high level, because in the later sections, I'm going to talk about data pipeline and data lifecycle in a little bit more detail. So the first one is the source where data gets generated. It can be various applications, it can be IoT devices, it can be OLTP databases like MySQL, PostgreSQL, Oracle, etc. And applications can be the applications from the domains that I have talked in the previous slide. So these are the places where data gets generated. IoT devices are the devices that are stored or fit in the truck that I was talking about, or the flights, or the ships, buses, trains, etc. So that's where data gets generated. So after the data gets generated, of course, these are all raw data. So if you try to use the data by itself from the source, it might not make too much of sense. So the data are ingested or collected from the sources, and there can be various type of ingestion or collection. There can be batch ingestion or streaming ingestion. Batch ingestion means that the data is collected or ingested at a certain frequency, once in an hour, or once in 6 hours, or once a day, etc. So you know how much data would be coming in, you know the size of the data that you're ingesting and collecting from these applications, devices, and different data stores. That's what batch ingestion is. Then you have streaming ingestion, wherein data gets generated continuously and ingested continuously, and at the same time processing is also done on those data continuously. One of the use cases is fraud detection that I told you in the previous slide, wherein streaming data is used, or the trucks which is taking fuel in it, and there's a particular path that it should follow. So what happens is that the IoT device which is there in the truck, it keeps on sending data continuously, and then the monitoring hub collects those data and creates dashboard out of it. So after ingesting or collecting the data, of course, it is stored temporarily somewhere. Why do I say temporarily? Because as I said that we are ingesting or collecting the data in its raw format. It might not make too much of sense in its raw format. So we'll have to do something with it so that it makes business sense. Now to do that, we have to collect and then store the data somewhere temporarily. And that's why data lake or data lake houses are used. Data lake is a place where we can store raw data, processed data, or data in any size and shape. So that's why it is called data lake. We can store structured data, we can store unstructured data, we can store semi-structured data also. And we also have something called Lakehouse, which is enabled by a technology called open table format. Now, once the data is stored temporarily, then it is processed or transformed. which is the processing layer. It can be batch processing or stream processing. Now, why you have two types of processing? Because we have two types of ingestion and collection. So what is batch processing? Batch processing is a processing where it would run in a certain frequency. It may be once an hour, it may be once in 6 hours, or once in a day. But stream processing is something which will process or transform the data continuously. As I said, fraud detection, wherein it will get the data and transform it continuously. Or the data which is sent by the IoT devices that are fit in the car, shown in a dashboard in real time. So after the data is collected, it is stored and then processed. And after processing, of course, it has to be stored again, because let's say you are creating reports, you are creating dashboards. So for those, you'll have to store the data somewhere. And that storage is similar to this one also. So we can use data lake, we can use Lakehouse, and we have some additional technologies also like data warehouse and databases. So you store the processed or transformed data using any of these technologies, and then the data is consumed by the consumption layer or by the consumption application. So those applications can be dashboarding application, which is being sent from an UI, which is written in JavaScript, or maybe reporting tool like Power BI, Tableau, etc. Dashboards can be created using Power BI, Tableau, MicroStrategy also. But I'm just giving you an example of another use case wherein UI applications can actually create dashboards out of the data which is stored in processed or transformed format. Then we have other applications also. It can be Java application, Python application, etc. And then there can be visualizations also which will be shown in the dashboard. So this is the entire data lifecycle. Source is a place where data is generated, and from there we collect the data or we ingest the data and store it temporarily in places like data lake or data lakehouse. From there we pull the data, do some processing and transformation based on the requirement of the consumption layer, and then store it again in a permanent storage like data lake, lakehouse, data warehouse, and database. Then it is consumed by dashboards, reports, reporting applications, normal front-end applications or back-end applications, or any visualization tools also. Now, if you want to think about it collectively, you see that the requirement essentially comes from the consumption layer. Of course, we have applications. Applications store their own data, which can be OLTP databases. But from there, when we follow the entire data lifecycle process, the users use the data which is there in the consume layer, or user use the data from the consumption layer or the consume layer. So the requirement comes from the right hand side, which is the consumption layer, and we store the data in the permanent storage as per the requirement in the consumption layer. And this is the entire data lifecycle. So it starts from source and ends in consumption or consumers. Now let's look at the technologies that are used in these various layers. First is the source layer. We can have multiple applications, IoT devices, and OLTP databases. So when I say applications, it can be Python application, Java, Golang, Swift, etc. It can be any application that you can think of. It can be JavaScript also, front-end applications. It can be SQL programs also. Then we have IoT devices, IoT cores, etc. Or it can be OLTP databases also, like relational and non-relational or NoSQL databases. For example, if you talk about relational or SQL databases, we have PostgreSQL, MySQL, Oracle, etc. Then if you go to the NoSQL world, we have DynamoDB, Cassandra, MongoDB, Couchbase, Redis, etc. And these are the places where application actually store the data. They generate data and then they store it in these operational data stores. And from there we ingest the data, right? And these are the various technologies which can be thought of as the sources or which reside in the source layer of the data lifecycle. Then you have the ingestion or collection layer, wherein we ingest the data or collect the data using either batch collection, batch ingestion, or streaming ingestion. For batch ingestion, we have technologies like Python, which is essentially writing code in Python which will ingest the data. We can have Java, we can have Spark, which is one of the very famous batch ingestion framework. We have tools like Informatica, Talend, etc. These also ingest data in batch format. Then you have streaming ingestion, wherein we use frameworks or tools or technologies like Kinesis, Kafka, Apache Nifi, Talend, etc. And these are the two ways that we ingest or collect data. After ingesting and collecting, of course, we store the data in data lake or lakehouse. Now, when we talk about data lake, in AWS, we have S3, which is simple storage service. In Google, we have Google Cloud Storage or GCS. And in Azure, we have ADLS or Azure Data Lake Storage. These are the famous data lakes that we have in or that are provided by the cloud service providers, S3 being the most popular. Then you have Lakehouse technologies like Hoodie, Iceberg, Delta Lake. These are all known as Open Table Format or OTF, which are enablers to implement Lakehouse in your entire data lifecycle. So after you store the data temporarily, of course, you need to process and transform it. And there are technologies and frameworks for both batch processing and stream processing. For batch processing, the suo motu is actually Apache Spark, which is the most famous batch processing framework. It used to be Apache Hadoop. So Hadoop has a subcomponent called MapReduce, and MapReduce used to be very famous in batch processing, but Spark is replacing that over a period of time. We have one more open source framework called Apache Beam, which actually merges both batch and streaming framework in the same application. So these are the batch processing frameworks that you can use to process and transform your data. For stream processing, we have Spark Streaming, which is Apache Spark only, but does stream processing rather than batch processing. Then we have Apache Flink, Kafka Streams, Apache Storm, etc. These are the stream processing frameworks, which can be used to process or transform your data and then store in the temporary storage, which can be data lake, lakehouse, data warehouse, or databases. So data lake I have already talked about, like AWS S3, Google Cloud Storage, ADLS. In lakehouse also we talked about Iceberg, Hoodie, Delta Lake, which are called open table format. In data warehouse, we have multiple technologies like Redshift, S3 itself, Hive, Snowflake, ClickHouse, BigQuery, etc. So these are the data warehousing technologies which are used to store, process, and transform data permanently. And the consumption layer uses these technologies to read data and show it in the dashboard or generate reports, etc. Then we have OLTP databases also like RDBMS and NoSQL, which are typically used in real-time dashboards or real-time applications. Then finally, you have consumption layer, which consume the data that we store permanently in data warehousing systems or data lake or data lakehouse systems. We have dashboard applications, reporting applications, etc. So in dashboarding, we have Power BI, Tableau, Click, MicroStrategy. AWS also has a dashboarding service called AWS QuickSight. Then you have Looker, and this falls in the category of reporting also. Then you have applications like Java, Python, .NET, C#, etc., which use the data which is stored in these data warehousing systems. We have other applications and visualization tools also, and Power BI, Tableau all can actually create visualizations as well. Same is the case with QuickSight. Now this entire pipeline or entire data lifecycle is called data engineering pipeline. Data lifecycle essentially means the data engineering pipeline. Another pipeline starts from here, which can be thought of as an application also, which is nothing but machine learning pipeline, which is used by AI/ML applications or GenAI applications. So where data engineering pipeline ends, machine learning pipeline starts. You can imagine that there cannot be any machine learning or GenAI without having a data engineering pipeline or data lifecycle. I've already touched based on what data engineering is, but let me give you the formal definition of data engineering. As you can see, the data is getting generated in source systems, then ingested, stored, processed, and then stored again. So there has to be a certain way of ingesting data. There has to be a certain way of storing data, transforming data, and again storing data in its final format. It is not same for all applications. For different applications, the pipeline would be different. The layers would be the same. We'll still have source, processing, transformation, and consumption layer, but the use cases are different. You can think of a finance organization and let's say an insurance organization. The way that the data has to be processed and stored and collected are very different from one another. We cannot use the same processing, we cannot use the same way of ingesting data, storing data for both the cases, because these are two different business use cases. That's why we say that data has to be engineered for the downstream consumption applications based on the business use case. And data engineering is that particular process of building the scalable system to ingest, store, and analyze the data. So data engineers build this entire data lifecycle or data engineering pipeline. It starts from source and goes till the storage layer, not the consumption layer, remember. It's still the storage layer. And also if you see in the source layer, the extension is not that much because data engineers do not go too deeper into the source layer unless it is OLTP databases. Even if it is OLTP databases, data engineers typically do not work on OLTP databases. That's why the arm does not extend till the end or the beginning of the source system. So this is how, or this is where data engineers work. The red portion is the places where data engineers work or what data engineers build. And the source system, as I said, I have kept it as a mix because data engineers do not work too much into the source system.